Hello everyone, welcome to the next session on ANSYS Workbench tutorials. In this session, we will analyze a water bottle which is made of PET material for its modal analysis. We will start by double clicking on the modal module. We will first go to engineering data and double click. Here we will add the material PET. The density for this material in kg per meter cube is 1380. Next, we will give the property of isotropic elasticity in megapascal. The value is 4000. The value of Poisson's ratio is 0.39. Then we'll go to project and update project. Next, we'll go to geometry and right click. Now, since I already have the model made with me, I'll directly import the model. Next, we'll go to model and double click. We'll first go to geometry. You can see here there are two parts. This is the cap of the bottle. So I'll just right click and suppress this one. I'm going to analyze only the body. Now if you want, you can still hold the cap and analyze. I'm just going for the body part. We will change the material to PET. Then we'll go to mesh, and here I'm going to directly update the mesh. You can change the sizing. You can make it more finer. We'll now go to model. Here I'm going to right click and I will insert fix support. At the bottom of the bottle, here these faces I'm going to fix. So click on apply. Once this is done, we will go to solution and we will just solve it. Here you can see there are 6 modes and 6 frequencies. You have got 6 of them because in analysis settings, if you check, the max modes to find are 6. If you want, you can increase or decrease the number over here. I am keeping it to 6 itself. So here we will right click, select all, right click, create mode shape results. You can see here there are 6 deformations obtained for these 6 modes. So we will go to solution and solve once again. So now let's go for the total deformation 1. We are going to animate and see this result. The maximum deformation is 185.6 mm, which is 18.56 centimeter, which is quite a high value. And the frequency is 592.88 Hz. Next is total deformation 2. You can observe the pattern of its motion by animating. You can see it is 593.85. Now this is very close to the first one. So your value of deformation will also be close to the first one. It is 186.08 mm, the highest value, which is over here, and the minimum value is at the fixed end. Then we'll go for the third one. You can see the maximum deformation is 271.5 mm for a frequency of 704.7 Hz. You can see where the value of deformation is more. It has changed. If you observe the first one, it was here. Second one, again at the top end. For the third one, you can see it is at the central position. You can animate and see its pattern of motion. It is different than the first and the second one. Both were different. Third one is also different. So once you get this one, we will go for the fourth one. You can see the maximum deformation is 268.07 mm for a frequency of 706.09 Hz. You can see the value of deformation is maximum again at the central position. For the third deformation, the value was 271.5. For the fourth one, it is 268 mm. So you can see again these two are closer because the frequency is also quite close. But you can check its pattern of motion. This is going to be a little different. Then we'll go for the fifth one. The maximum deformation is 269.69 mm for a frequency of 831.04 Hz. The frequency has increased, but you can see the deformation is closer to the third and the fourth one. Again, you can animate and check this result. You can see. Then we'll go for the sixth one. Here the maximum deformation is 268.03 mm for a frequency of 840.05 Hz. Again, these two do not have too much of a difference, hence the value of deformation is also quite closer. But the pattern of motion is quite different, so let's check its pattern. You can see a crushing kind of effect which could happen in this bottle if this frequency is touched. We analyze for modal frequency, which is the natural frequency of the body, such that we know the values which we do not want to tap, such that we are avoiding any destruction for that object. So these are the frequencies which you do not want to touch for this body. If the frequency of any object which comes closer to this bottle will match, then there will be resonance and there will be destruction of this bottle. Again, these frequencies are quite high. It is quite difficult to reach these frequencies. So at low frequencies, this bottle seems to be very much stable. If you don't want to see these meshing, which is a tetrahedron type, as you can see, you can just go to edges and click on no wireframe such that you are able to see the bottle only. Here you can see there are bands formed of different color. These colors over here indicate the value. So you can read the value from here, like this blue. Royal blue is from 0 to 29.781. So wherever this color is there, you can go to probe and you can just check over here. Somewhere it seems to be 0, somewhere it is 12, somewhere it is 13, 14. So it is between 0 to 29.78. The next blue which you see over here is between 29.78 to 59.56. So if you check out, that color is over here. So this is where you will see that value range. So accordingly you can see the colors and you can see its value from here. If you do not get the direct value, you can use this option of probe. Max min, if you click on them, you will find the maximum and minimum for a particular deformation. So that right now you can see this position has maximum value, this position has minimum value. Maximum again is from 238.25 to 268.03. Highest being 268, but the range of this color red is from here to here. So you have to check what is the color in that position and you will have to correspondingly check the value. If you don't want to see the max min, click on it once again, it will disappear. If you don't like these banded colors, you can just go to contour and choose smooth contour such that the colors blend into each other. Now how you want to see them is completely your choice. You can also see them as bands and you can also see the wireframe by going back to this option of edges and selecting show elements. So you will again see the elements. Whether you want to see the elements or you don't want to see the elements, it's your choice completely of representing the result. So with this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.